Okay, today we're going to go over balancing equations, and before we start I just want to let you know that this is quite a complex idea for you to wrap your head around. We've gone through the law of conservation of mass, which says that the matter that we start with in our reaction has to be the same at the end of a reaction, and that is a main principle for balancing out chemical equations. Whatever I start with, I need to have the exact same numbers of everything at the end. I can't lose it along the way. My matter is never created, nor can it be destroyed. It can only be converted from one place to another, and that's what happens in our chemical reactions. So, let's get started by identifying the different areas within a chemical equation. So on one side over here, we have our reactants. And what our reactants do, you may have 2, 3, 4, 5, 1 in this case, and those reactants are what, as the title implies, react with each other to cause the reaction. So that I'll color tag in black. The next one that we have is our products, and I'll identify them with green. Our products are on the right-hand side of the arrow. Reactants on the left, products on the right. And this is the outcome of our chemical reaction. So my products are on the right, reactants on the left. The next one is my coefficients. My coefficients are any of these big numbers that you see out the front. When it comes to balancing chemical equations, you can only change coefficients. You can't change subscripts, which I'll get to next. The big numbers that are out the front here apply to each element within the compound that it's written before. So in this case, the 2 out the front in the first reaction from our reactants applies to both the Hg and the O. So I have 2 Hgs and 2 Os stuck together. In my products, on the other hand, I've got 2 Hgs, just 2 by themselves. They're not together. So I've got a Hg and an O in my reactants, and I've got 2 sets of those. So my Hg and O stuck together, 2 sets of that. In my products, I've got 2 singular Hgs. They're not stuck together. The next one is my subscript, and I'll color code that one in red. My subscript is the smaller text that comes directly after an element symbol. So in this case, the 2 applies only to the oxygen. In the first case, it applied to both the Hg and the O. So if I had a 2 after the O in my reactants, instead of out the front, I would have 1 Hg and 2 oxygens combined together. When it's at the end, it means that those 2 oxygens would be combined together. So it's our O2 that we breathe in. My elements, I'll do this in yellow. Each part within here is my element, and you need to make sure that you can identify the different symbols, because it's really important when you're balancing a chemical equation that you know all the different symbols that they come with. Remember, the elements are then by themselves, compounds are when they are stuck together. So let's have a look at some of the steps to balancing out a chemical equation. You need to make sure your equation is written in symbols, not in words, because when it's written in symbols, then it can have subscripts and coefficients and those kinds of things. When it's written in words, it doesn't matter how much of everything you've got, you just chuck the words on the piece of paper and you're fine. What you need to do for step 2 is to count and compare the number of each type of atom that you have on each side of the arrow. So this is where we split our reactants and our products. We put the line down the middle, count how much you have of everything in this side, count how much you have of everything on this side. Then you need to see where the numbers aren't the same, and this is where step 3 comes in. You need to determine the atoms that need to be balanced. So in some cases, some of them will already be balanced, so you don't need to change them. But in changing other ones, it will disrupt how many of other elements that you have. So you need to make sure that you change everything as needed. Number 4 says to balance atoms one at a time by adding coefficients on the appropriate side. What this is telling you to do is to add one number gradually at a time. So don't just instantly leap up to doing a number 6 as a coefficient when you could go by one at a time. If you're going to make that big leap, you need to be 100% certain that it's going to be right, because it becomes really hard to backtrack. It's easier if you take that little bit more time, think the process through, and just gradually go through it step by step by step. Usually when you're balancing a chemical equation, the pattern is to go metals, non-metals, hydrogen, and then oxygen, just because it makes it a little bit easier to balance out. Don't stress too much at this stage if you don't remember that order or you don't do it in that order. It is just an easier way to do it for later on. Then what you need to do is to recheck each atom on each side after the changes to see that it's balanced. And what that means is to double check. So 5 H2Os, 5 H2, 5 times 2 gives me 10 O, 5 O's, 10 H's, 5 O's. And then see if it's the same on both sides. That's what it's talking about. So let's do an example. So here I have C4H10O2 reacts to form CO2 and H2O. So the first thing that you're going to want to do is draw a line directly underneath where the arrow is. I'm going to split my reactants on the left from my products on the right. And then what you need to do is count how many of each element that you have. So when I would do these, and before I even did this for you guys, I rewrote them out again to make sure that my answers were correct. And when I did it, I've rewritten the equation to make sure that I've got the right numbers of everything, because undoubtedly when you write things down, and I do this all the time, I might copy a number down wrong. And that's a really simple mistake that can be avoided, and you don't want to be making silly mistakes like that. So the first thing that you do is write down all the symbols. So I've got a C, H, O, so I'll put down C, H, O, and on the other side C, H, O. And I'll keep them in the same order on each side because it'll make it easier for me to compare them from one side to the other. Then what I need to do is go back and count how many of everything I have. C4 tells me I have 4 carbons in my compound there. H10 tells me I've got 10 hydrogens, and O2 tells me I've got 2 oxygens, and that should be an O, not a C. This side, I've got 1 C, here I've got 2 oxygens, and here I have 1 oxygen. 2 plus 1 gives me 3, and my H, this bit here, is a little 2. Okay, so nothing to start off with is balanced. 4, 1, 10, 2, 2, 3. Now this is going to be a bit harder because this is uneven. It's going to make it a little bit harder for us to balance out. So the first thing that I can do is, I know that this side here is, for my carbons and my hydrogens, are both lower than this side here. This carbon here is just 1 by itself, so I can easily turn this into a 4. If I put a 4 as my new coefficient, let me just change my color so that you can see this nice and clearly. If I put a 4 out the front of my CO2, 4 times 1 changes this into a 4, and 4 by 2 changes this into an 8, plus the 1 over here, it's now a 9. So now my carbons are the same, my hydrogens still aren't the same, and my oxygens still aren't the same. So the next one that's going to be really easy to do is my hydrogens, H2, and I need to get to 10. So what times 2 will get me 10? 5. 5 times 2 will make this a 10. So if I put a 5 out the front here, 5 times 2 is 10. 5 oxygens here, plus the 8 oxygens here, will leave me with 13. And it's still not balanced. I can't add a number out the front to this O2 because every time I add another oxygen, I'm going to be adding 2 oxygens at a time, like I did with my hydrogens here, not just the 1. So what I need to do, and it's hard to recognize this at the time. When you're looking at things and it's not even like it is now, what I can do is I can double everything that I've got. So instead of having 1 C4H10, I could have 2 C4H10 instead. So turn this into a 2. 2 times 4 is 8. 2 times 10 is 20. Okay. 4, change my 4 to an 8. 8 carbons. My carbons are still balanced. 8 times 2, 16. Change my 5 to a 10. 10 times 2 gives me 20. 10 plus 16 gives me 26 oxygens in total. Half of 26, 13. So I put my 13 out the front here, and this becomes 26. 8, 8, 20, 20, 26, 26. So my finished balanced equation, I'll write it out again, becomes 2C4H10 plus 13O2 gives me 8CO2 plus 10H2O. Make sure you're going back to the original equation to double check. When you get that odd number, don't think, oh, it's going to be the end of the world. Double everything else so that your odd number now becomes an even number. But if you double everything, then you don't need to worry about adding one at a time to everything else. So double the odd number, double everything else, turn your odd number into an even number, and then go back and see how many of that you would need in your pairing. So it's not too hard. All right, let's do one that is a lot easier. All right, the next one, C2O3. It doesn't matter how easy the equation is, follow the steps. So it's written as a equation, not a word. So I draw my line down the middle. Step 2, count and compare. C2, O2, O3. Step 3, determine the atoms that need to be balanced. Both sides need to be balanced. I need to get the same number of each. If I add 2 here, 2 times 2 becomes 4. That's not going to get to 3. I need to make 3 an even number. And how can I do that? I can multiply it by 2, because then I'll turn my 3 into a 6. 6 divided by 2 would give me 3. 3 times 2 equals 6, and both sides are even. So it would be 3O2, 2O3. While I said that this one here is easy, it's only easy if you can see the common denominator between 2 and 3. Here I took the 2 from my subscript and moved it to the front. I took the 3 from this subscript and moved it to the front. But you can't do that with every equation, so don't fall into the trap of thinking you can do it all the time. You just need to find the common denominator and then work from there. Okay, next one. FeH2O, Fe3O4H2. All right, split down the middle. Write them out. Fe1H2O1. Fe3H2O4. Okay. My hydrogens are already the same. So as much as possible, I want to avoid doing anything to my hydrogens to start off with. My iron isn't the same, but this guy here is only my first ion on my reactant side. It's only going to be multiplied by 1. So I want to kind of keep that until the end to easily be able to balance it out. Does that make sense? If it's 3, 6, 9, 12, whatever number I get on my reactants, on my product side, is just the number that I have to put on the reactant side. So it's nice and easy. So let's start with my oxygen. On the right hand side I have 4, on the left hand side I have 1. So it's nice and easy for me to do. I just need to add a 4 out the front. This guy here now becomes a 4, but my hydrogen changes as well. 4 times 2 is 8. Oxygens are happy, hydrogens not so happy. I've got an 8. And I can only add 2 every time, and I've got 2 to start off with. So I know that 4 times 2 gives me 8. Same, not the same. I've got 3 on the right, 1 on the left. All I need to do is add a 3 at the front. 3 times 1 gives me my 3 Fe's. So my equation will be 3 Fe plus 4 H2O gives me Fe3O4 plus 4H2. Remember the difference between the little numbers and the big numbers. Little numbers apply to the element that comes directly before them. So Fe3 tells me I have 3 Fe's. O4 tells me I have 4 of those. 4H2O tells me I have 4 H2 pairs. 4 lots of those H2 pairs. So I've got one more example that we're going to go through. While this one here looks more complicated, the equations are getting longer, don't worry about it. Doesn't matter how many letters there are, doesn't matter how long the equation is, the steps are exactly the same for both. So, split it in half. Write down your elements. N, A, S, O, C, A, C, L. N, A, S, O, C, A, C, L. The same spots on either side makes it easier to compare. How many NAs do I have on the left? 2. How many S's? 1. How many oxygens? 4. Ca, 1, Cl, 2. Let's go this side. Ca, 2, S, 1, O, 4. Na, 1, Cl, 1. Not the same. Same. S's are the same. My oxygens are the same. My Cas are not the same. Oh, they are the same. 1 on either side. Cl2 on this side, 1 on this side. This is why it's important that you go back and double check. Even I make mistakes. I'm just a human being and I'm just reading some numbers. And from time to time, you'll read the numbers wrong because there's so many of them on the page. Or you'll read the wrong element for those because their element symbols are the same. Go through it, double check it, then be happy with it. Don't just rely on the first answer that you get. So what I need to balance out are my CLs and my NAs, and I've got 2 on the left, 1 on the right, 2 on the left, 1 on the right. And on my right hand side equation, I notice that my NaCls are grouped together. So I want to go from 1 to 2. So I put my 2 out the front on my NaCl. That now becomes a 2, 2Cl. That now becomes a 2. 2, 2, 1, 1, 4, 4, 1, 1, 2, 2. My equation is balanced. So my final equation, Na2SO4 plus CaCl2 gives me CaSO4 plus 2NaCl. Doesn't matter how long the equation is, it doesn't matter how many parts there are, you just need to follow the simple steps. Write the equation out. Divide your page in half, right under that equation line, that reactant arrow. Count how many of everything do I have on this side? How many of everything do I have on this side? Where are they the same? Where are they different? If one side has less than the other, up your lower side to the higher side. You can't drop the higher number down. It's not how it works. You can only lift up the lower number. So whichever side's the lower, that's the side that will need a coefficient added out the front. Whatever side's the lower side, it means it might not change for now, but you may need to go back and change it again. Remember that first equation that I did, where I had everything and then I needed to go in and double everything? That's perfectly fine. If you get to the end and you go, oh, but now I have to add an extra hydrogen, and now hydrogen's unbalanced. So then you have to go back and change your hydrogen again. It happens. That's what happens when you're balancing chemical equations. The process repeats itself over and over again until you find the solution. If you're spending a significant amount of time on one question and it's really, really starting to annoy you and you become quite frustrated about it, that's when you ask for help. If you're becoming frustrated because you only need to repeat the process one more time, maybe not the best time to be frustrated. A couple of times, see how you go. If you still can't figure it out, then ask your teacher for help. It's not the end of the world.